Okay, everybody, we are doing the last section from chapter 2. So this is 2.6, and it's kind of a nice way to finish things off. We've been each day learning one new skill or new topic, and today we're putting them all together. So the title is Combined Transformations. You'll notice at the top here, I've written SRT, and again, that's the order to apply the transformations in. Actually, to tell you the truth, between S and R, it actually doesn't matter which one you start with first. If you want to start with reflections first, it's no big deal. The key thing is, though, that the S and R have to come before translation, so the translations part has to be last. If you do that first, you're going to end up with the wrong end result. So that's just a quick thing to watch out for. Notice that we're starting with y equals f of x, and we've each day been doing, or I guess in the videos, have been doing a little bit at a time, but if I were to apply all of the possible transformations, then my y equals f of x would end up looking like this thing in the red box. Y equals a f of b bracket x minus c plus d, and that's like a, b, c, and d are representing all of the different types of transformations that you could get. So at the bottom here with this star, I've written that horizontal expansion and horizontal compression factor must be factored out of the x term. So what I am talking about is right here, see this b value? If that's, like right now it's in factored form, but if you get an equation where it's not factored, then it's our job to factor it out to make it look like the equation in this box. The thing is, this isn't actually new for you. You did this last year with parabolas. It's been a while, so you might have forgotten. So not to worry, I will build in review as we're going through it, but it's good to know, or comforting maybe to know, that you have seen this before. But it's possible you didn't know what it was called or exactly what it was. We're going to be doing this with lots of new functions, not just parabolas this year. So let's start off with our first example. It says if y equals f of x is transformed to y equals negative 3f bracket 2 bracket x plus 5 minus 4, what does the point 43 become? Okay, so we want to figure out what it's going to become. So I think a good approach to use, because there's so many things going on here, I like to use color to organize everything and to keep track of all this stuff that's going on, because this kind of looks like a lot when you first look at it. But if we organize it and split things up, you're going to find it's actually not too bad. So I try to always lead with that same question, and that is when we're looking at the stuff in the equation, like, does this affect the y value or the x value? So right now, if we're starting with the x value, or the 4, then in my equation, I want to pick out the stuff that affects my x value. So that would be like this 2 here and this plus 5 here. Nothing else in there is affecting the x value. So I think that's a nice starting point, is to get some clarity by color coding them. I'm going to do the y values using blue, just so I can differentiate between them. So now I'm looking for the stuff that affects my y value. So I know the negative 3 all does, and I know that this minus 4 also does. So just by doing that, I'm able to start to figure out a little bit of like where I would go with this and what it's going to sort of look like. So I showed you, I guess it was the last video, I showed you this approach that I'm going to use right now as well, because I think you're going to find it kind of helpful. So instead of 4, 3, I'm going to call this point xy, and then over here I'm going to write x and y, but I'm going to leave a bit of space to fill in like exactly what I am doing to this stuff. So I'm going to focus on the x part first. If there's a 2 in front of here, that means that what I am doing to the point is I'm going to multiply it by a half, because remember with x it's always the opposite. And if I have a plus 5 here, that means that this is instead going to be 1/2 x minus 5, because it's the opposite of what I see here. So I hope that that makes sense to everybody, and I'm trying to be consistent by using the same method as what we did in the last video. And let's do the same thing with the y value. So let me just get to the blue here. So I have my y value here. If I take a look at it, there's a -3 there. So I know I'm going to multiply my y value by -3. And then I have a -4 at the end, so whatever result I get, I know I'm subtracting 4 from it. So basically this stuff that I've done in green, like mainly in green, just sort of lays down the groundwork for what we are going to do to the point, to transform it to the new point. So then what I would do is I'm actually working with the point, and I hope you're all okay with this, but I think I'm done with switching all these colors. I think that I've gotten my point across by doing this. But what I would be doing for the first one here is 1/2, instead of x, I'm going to plug in 4, and then -5. And then for this part, it's going to be -3. Instead of y, I'm plugging in the 3 that was there, -4. So I hope it's clear where this is all coming from, but basically this is giving me a sense of what my new point will be. So then we just work our way through what this is going to be. So I actually end up with 2 here, 2 minus 5. So -3 is my new x value. And if I look at this part here, I would get -9, and then I'm taking 4 more away from it. So I get -13, so there's my new point. It says, what does the point 4,3 become? Well, it becomes -3, -13. If we were to talk about all the different parts, I guess it's important to mention what all the transformations are. Maybe I'll just verbally tell you what they are. I didn't actually ask for it in here, but it's helpful to talk about. This -3 tells us there's a vertical expansion by 3. And if it's a minus sign, that means your y values would change, so it's going to be flipped in the x-axis. So that's what it's telling us there. That means there's a reflection in the x-axis. If I take a look at this 2 here, the factored out 2, that would mean that I'm actually multiplying it by a half. So it's actually a horizontal compression, right? So I know it looks like a 2 there, but we're multiplying by a half, which means horizontal compression. This +5 means I'm translating it 5 to the left. Because of the +5, we'd go opposite. And then this -4 means it'd be a vertical translation 4 units down. So I hope that that is clear based on, I guess, the last few videos and just putting it all together now. So that's basically, those are the transformations that took place to get us to this new point of -3, -13. So this is one of many strategies or methods to apply your transformations to a point. I've tried a bunch of different ways over the years, and I find this one makes it super clear. It's a step-by-step manner of getting there, and it's just, I feel it's pretty clear and almost takes the confusion away and makes it not so bad, because it has the potential to get kind of confusing. So I hope that makes sense. And here's the next one. Given y equals f of 4x plus 12, which transformations have been applied to y equals f of x? Okay, so I'll just get into the habit maybe of repeating this a little bit, but what I would suggest is anytime I've gone through the first example, like you probably need some help or guidance in the first example, but after that point, if I were you, I would pause the video and I would actually try it yourselves. So this looks or resembles somewhat the one that we just did. The only difference is you have to factor out the 4 because this doesn't quite look like the red box that we started off with. So you can notice that in the red box, everything's all factored and looks nice and clean and straightforward. So it's our job to do that when that hasn't already happened for us. So if case, we would have y equals f of, and I just need to factor out the 4 there. So instead it's going to be 4 bracket x plus 3. So this is actually what it ends up looking like, and the reason is this makes it super clear that that 4 is affecting the x values, but it's going to be multiplied by a factor of a quarter, and so this is giving you a sense of what transformations are going on. So there's a stretch where x would be multiplied by a quarter, and then it would also move 3 units to the left according to this, because it's a plus 3, and we know that with x's we always do the opposite. So I didn't actually answer the question yet. We've just done the work to set this up so that we are able to answer the question. But if we take a look at this, we would have a horizontal compression by, let me say this, it's by a factor of 4, but that means that we would multiply by a quarter. So I'm going to write that in brackets so it's super clear for you. So it's being compressed by a factor of 4. So we're multiplying the x values by a quarter. And then this part here, the plus 3, means horizontal translation, 3 units to the left. Okay, for the next one, if 3, 2 is on the graph of y equals f of x, what point is on this graph? Okay, again, if I were you, I would pause it and try it yourselves. And then to get to the solution, we can tell, like, this doesn't look like that red box. We need to do the work to make it look like that red box. So we start factoring. That's all good. -4, that's going to affect the y values. And then we run into some troubles when we get into this part, because there's a couple of things going on. The x has to start first, so we're going to swap these two. So we're going to do that and that. And then we also need to factor out a -3. So if I pull out a -3, it's going to leave me with an x at the front. Ultimately, I'm dividing both of these by -3. So I actually get an x minus 2 that's in the brackets, and then that plus 1 is good to go because it's already separated. And so now when we look at it, it's way easier to be able to look and pick out what the transformations are. So actually, I regret doing that. I'm going to get rid of all of those, and I want to color code them so that it makes it nice and clear for you. So if my original point was 3, you know what? I'm going to get you into the habit of, can I pull this off and not go crazy doing this? Yes, I can. Okay, so if the old or original point was xy, I want to think in here what I'm going to have instead of xy. So I don't know, I'll do it like this so I have tons of room and hopefully make it work. But basically, I look at my equation and I think, okay, which of these numbers or coefficients, I guess they're not all coefficients, which of these numbers represent or affect the x values? Not the -4. This does, so there's a -3 there, and this does, but nothing else. So if I have a -3 in front of there, that means that I'm going to multiply by, now this, I think this might be the first time this came up, but we're going to multiply by a negative. But if there's a -3 there, it's actually -1/3. That's what we're multiplying the x values by. And if here we have a -2, that means we're actually adding 2 to it. Then we do the same thing with the y values. So that's going to affect my y values, so is that. I hope that the colors are making it clear to you what's going on here. So I'd have, well, if that says -4, it's actually going to be -4y. And then if it says +1, like with the -4 and the +1, you just take it as you see it anytime you're dealing with the y values, when the y is isolated on one side. So that's basically what we would do to the different points. Well, different points, we only have the one point, but you get what I'm saying? So I'm going to take my point now, 3, 2, and I'm going to do all of this to it. So I'm going to plug in. So negative 1 over 3 multiplied by 3. Look at that. How nice that it's a nice whole number that it works out to. How convenient. That's probably not realistic, but it works for us, so we're going to go with it. And then here we have negative 4 times y. Notice the y value here is 2 plus 1. So everything else I've kept the same. I've just plugged my points into here, so 3, 2, and everything else is just like the stuff that we did above here. So I hope that this step-by-step method makes it super easy and clear for you as to how to go through it. And then we're just simplifying this. So you can see here that these nicely just conveniently cancel out. So I just get negative 1 plus 2, so I get a 1. And then here we have negative 8 plus 1, so this ends up being negative 7. So after all of that, our point is 1, negative 7. And this has the potential to be kind of complicated, but if you go through, pick things out, do it step by step, it makes it a lot easier to work with. Okay, next thing, if the 0.31 is on, it's on an inverse function, then what point is on this function? So again, I would pause and think your way through this, because we have, although I haven't exactly shown you this, we've done some version of this before. This is a nice way to put a whole bunch of different concepts together, so I hope that you're able to at least try doing it on your own. You're just having to sort of think or work backwards to get to this. Let's think our way through this. So, first of all, we have some stuff that we have to clean up here. So let's maybe start with that. We have y equals 2, that part's fine, f, and then when we look at this, we can see again that we kind of need to swap these or rearrange them. And when we rearrange them, we're going to have to factor out a half. And so I wanted to move the x to the front. So I'm swapping them and factoring at the same time. If I'm dividing this by a half to pull it out, you would ultimately, to end up with a 1, if I'm dividing by 1/2, that's like flipping it and multiplying it by 2. So I actually just have a 2, and then everything else is good to go. Am I missing a bracket here? I guess I am. Like that. Let me clean this up. -1. So at least this makes it easier to work with, or a bit more clear in terms of what we have. So let's think our way through this. This is telling me that 3, 1 it's on the inverse graph, or it's in the inverse equation. So we learned about the relationship between the original equation and then the inverse equation, and that is that we swapped the x and the y values. If we know that, then working backwards, if this is my inverse, then my f of x must have the reverse of this, meaning I just swapped the x and the y. So the 0.13 must be on f of x. This is just, I think it's the last video? I don't know. I've lost track of of which video it was, but we went through the relationship between the original function and the inverse function. So that is why the x and the y just get swapped. And so we end up with this. And maybe I can use the same approach as what I've been using to show you so far, just to keep things consistent. Instead of x, y, I want to look at what this now becomes. So maybe a good way to do this is, if that's my x value, I want to go through and pick out the stuff that affects my x value. So if I see a 1/2 there, that means what I'm ultimately doing is multiplying by 2. And If I have a plus 2 there, that means I'm subtracting by 2. So that takes care of that part. Now let's get to the y's. So if there's a 2 there and a minus 1 there, that means I'm multiplying by 2 and I'm subtracting 1. So the y's are much easier. You just take it as you see it because the y is isolated in that equation. That's the reason for that. So now that we know that, we can go back to the point we were working with. So it's not xy, it's actually 1, 3. So then I know what I'm doing to the 1, 3. I'm doing 2 times 1 minus 2, and I'm doing 2 times 3 minus 1. I'm kind of flying through because I feel like at this point it's the same thing that we're doing, same thing as the last one. So when I go through this, I just get 2 minus 2. And when I go through this, I just get 6 minus 1. So my new point becomes 0, 5. So know this. They might look like they're getting harder or more complicated, but it doesn't if you view it in that same step-by-step manner. If you break it down and go through it one little bit at a time, you'll start to pick up on the pattern that it's kind of the same thing that we're doing over and over again. It's just each time there's one new little thing or new little step that's added in. In this case, it was just the fact that it's an inverse instead of the original. So use that to help you to simplify things and to work your way through them. We're almost at the end, so hope you're still following along and hanging in there. Generally, if y equals f of x has a point mn, then y equals a blah, 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 blah has the point okay. So this is kind of good to see. The only reason, like I could have started with this, but I thought it would be easier to take in if we started with some actual numbers and examples and then brought it to this potentially confusing thing that has no numbers and just a whole bunch of variables. But now that we've done that, we'll be a lot better at figuring this out. If we are looking at m here, again, let's use that approach. What's going to affect the m value? And it's those. And if I look at n here, that's going to affect my n, and that's going to affect my n. So when we go through this, our point becomes, well, it would have been, I don't know, I'm not going to color code it anymore, I'm tired of that, but I think you get the point of where it's all coming from. But if we have a m and we have a b here, we're actually multiplying by 1 over b times m. You could say m over b, I just think this makes it super clear for you to see. And then it's going to be plus c, because it's the opposite of what I see happening there. And over here I would have a is going to be multiplied by the n value, and then I have the plus d afterwards, so it's going to be set up like this. So just to remind you, maybe I'll go over this, it's m and n are the values or the points that we were starting with, and the other stuff is all the transformations and the stuff that we applied to it. Okay. This time we're given a graph, and given that, we want to graph this equation. So I think, again, it's helpful if we break this down into steps. And so here's how we can go through this. We're basically doing the same thing as what we've been doing back here, but notice in each of these examples, you were given a point. So each time you were just working with one point. No big deal. This time you're not given the points, but you're given the graph, so you can get the points. And you even have some flexibility, although, especially since it's a graph I just randomly sort of drew, you can tell, like, in math, you're always looking to simplify. You're looking for the easiest way to figure out what you're working with. So the easiest way is probably to take these 3 dots because they're right at a whole number. We know what it is, so it's a little bit easier to work with. So if you look at this, it's negative 1, 2, 3. So, oops, that's not what I want. It's going to be the point negative 3, 0. that's going to be the point 0.04, and that's going to be the point 0.30. So knowing that is a good place to start because it sort of allows us to figure out how to go through this. Okay, so then maybe a good way to go through this is the same type of approach. So if we have our original points, and this time I'm saying like x, y, so like the -3, 0, the 0.4, and the 3.0 is what could go in this little column. And then I want to think of like what it's going to become. So again, I want to look at like what, this is already all factored and good to go. So we don't need to do anything with that, but we do need to point out which transformations we would apply to this. So if we have a minus here, and that's a +1, so we could say it's a minus x minus 1. That's ultimately what we're doing to it. And instead of y, it's going to become -2y plus 3. So this is giving us a really good idea of what to do with each of these points to basically come up with what the new point would be. So luckily I'm able to change the size because maybe it would be helpful. Yeah, no, I know what to do. I got it. Okay, here's what we'll do. I'm going to write the old points here. So I'm going to start with -3.0. I'm going to go with 0.4, and I'm going to go with 3.0. You don't have to do it this way. I just feel like this makes it super step-by-step and super clear and easy to follow, hopefully. You can let me know when I see you. So if we're starting with -3, then what that means is I am plugging into here. And this time, like, I'm not going to write out every single little step. I know that you all know how to add and subtract. So let's just talk our way through this. If we take -3 here and we plug it into here, ultimately I'm doing -3. So it's actually just 3 minus 1. So my x value here just ends up being 2. That's my new x value. Okay, I had a 0 y value here, so my y value there just becomes 3 because the 0 wipes that out and I have +3. So I have the point 2.3. And maybe what I'm going to do is, oh no, I can do this. So 2.3, might as well start to graph it. 1, 2, and 1, 2, 3. I'm going to mark it with a little x so we can keep track of what's going on here. Okay, 1 down. Let's go to the next one. 0, so that's just going to be -1, right? When I plug it into here, 0 minus 1. Then this is a 4, so I'm going to do -8 plus 3, so I get a -5. There's my next point, -1, -5. There's my next point. I'm going to check that off. 3, 0, okay, I'm plugging in 3. -3 minus 1 is -4. And my other point here was 0, my y value, so that's going to be 0 plus 3, which is 3. So -4, 3. -4 and up 1, 2, 3. So notice what this graph has done. It actually, well, I guess before I do that, oh gosh, I hate doing this on camera in front of everyone because if you've ever been in my class before, you know that I'm awful at this. But I'm going to blame this computer or this writing tool. It's harder than it looks, and I'm sticking with that excuse. But basically, this is what happens to our graph, and because you know about transformations, you can think your way through it. There's a flip clearly over the x-axis, and there also is one over the y-axis. And when you look at the equation, that makes sense to us. It also has been stretched out by a factor of 2, and again, you can make sense of that by looking at it. And it's also been moved up 3 from where it would have been. So you can sort of take a look at all of these things and double check to see that it does in fact make sense. And that's probably the quickest, easiest strategy or method to go through and do this. Know that we just did the same thing as we did in all the other examples. It just was given to you or presented in a different form. It was on a graph, so you had to find the points in order to do the work to be able to graph it. So there is your suggested assignment for this, and that was your very last section from transformations, which, as a reminder, is the theme of this whole course. So transformation means change. Also the theme of your life, especially right now. So that's it. And I guess this will be the last video that I give you on this for this online portion for transformations. But in the Teams channel, I'll give you some more information about assessment. So yes, I know you learned this all online, but yes, you are going to get an assessment, and stay tuned for more information on that. Okay.